Yours actually, they're just not visible.
It's not even a thing. Okay, here we go, guys. Now you've got to stay on task. Kaven? Well, I'll tell you about that in a bit. Now, kids, I am going to record this. Maybe. And so I need you to work with me. Okay? Now, kids, so kids, this is slide, what, 31, 32? Kids, we need to fill in the blanks. So here we go. Kids, I'm going to type and talk at the same time. I want you to fill in your blanks. Here we go. Last week, we talked about Kepler and Captain Obvious Kepler. Kids, today we're going to talk about Newton. Now, kids, Kepler was wondering about the speed of the planets closer to the sun and why they were going so fast. He never figured it out. Newton figured it out. Okay, so kids, Newton noted that an object falls, okay, an object falls towards the earth because the earth and the object are attracted to each other by, well, kids, it's not by love, it's by gravity. Okay, what's that? I know, right? Why don't they just fly into the sun? And we're going to talk about that. In 5, 4, 3, 2, 1. Let's go to the next slide. Maybe. Okay. Now, kids, the force of this attraction depends on 2 things. Kids, it depends on how big the objects are, so the mass of the objects, and it depends on how close they are together. So kids, the distance between the objects. Now, kids, if you take 2 semi-trucks fully loaded, and one is in Laurel and one is in Billings, kids, are they going to have any effect at that distance? Kids, what if they were heading for a head-on collision and they were both on Old Laurel Road? Yeah, then kids, they're going to have a big impact. Well, kids, it's the same thing with gravity. Got it? Okay, in 3, 2, 1. Do we have this? Come on, guys. I'm typing and talking at the same time. Ian, we're being recorded.
What?
We're being recorded. So you need to behave. Okay, in 3, 2, 1. Going on. Now, kids, Newton's law of universal gravitation. So if the distance between these 2 objects increases, kids, the gravitational pull or the gravitational attraction, guys, we have to put in a text box here. Okay.
I don't see that online.
Okay. And I'm going to make my text just as big as I possibly can. All right. Kids, if the distance between the 2 objects increases, what's the gravitational pull going to do?
It's going to increase.
Increase?
Or decrease.
Decrease. Yeah. Decrease. Okay. Move that up a little bit. There we go. Okay.
Why am I taking it all down? Because mine doesn't even have the whole thing. It just has the thing that's like question mark.
Okay. In 5, 4, 3, 2, 1. Now, kids, you understand this. Havens? You understand this, guys. If we take 2 magnets and we put them on the ends of each table, are they gonna do anything?
No, not
No.
if they're really. Well, not if they're not really.
What if we put them closer together?
No.
Then kids, they come together, don't they? What if we move them apart again, kids? Are they going to come back together?
They'll try.
They'll try, but if they're not close enough
Or strong enough.
Exactly. Okay, good. Now, kids, let's move on. Okay, the masses, okay, the larger the masses are, the larger the masses of the 2 objects, and kids, because it's mass and distance, so kids, the larger the masses and the closer together they are, it's the greater that force of gravity. Now, major mind blow. Guys, what would happen? What would happen if Jupiter and Mercury traded places in the solar system?
Oh, everything would be messed up.
It would be messed up. Kids, think about the size. Think about our model. Think about the size of Jupiter next to the sun. Yeah. Okay. Holy guacamole, that would be awesome.
Everything would be so
Okay.
off.
Well, it would be.
It would be closer to us.
Yeah, it would be.
Meaning.
And it would pretty much block out the sun like all the time. That couldn't be good. Never mind. Don't put Jupiter next to the sun. Okay. Now, guys, in 5, 4, 3, 2, 1. Bingo.
Bingo.
Maybe. Okay, here we go. Now, kids, remember this slide, because this slide is going to give you an answer for your orange box at the end. Okay? And your orange box is where you have to look up the information. Guys, I'm telling you where to find the information. Are you with me?
Yeah.
Okay? Kids, the law of gravity explains why the planets orbit the sun and why the moons orbit the planet. And kids, we have more moons because some planets have more than one moon. Okay, that's why they said it like that.
Isn't there a
Now-
planet with over like 20 moons?
Oh, honey, Jupiter has like 69 moons.
Nice.
Yeah, it's a lot. Now, guys, remember this slide because it's going to help you answer one of your questions. Okay. So the sun, guys, has a lot of gravity, a
Yeah.
lot. But honestly, guys, I mean, it makes sense because it's like 99 point something percent of our entire solar system.
Why do the planets get pulled into the sun?
What?
Why don't planets get pulled into the sun?
Exactly. Why don't the planets get pulled into the sun? Well, guys, we're going to talk about that.
Like,
Ready, set, let's go. Kids, it's called inertia.
What the heck?
What the heck? Okay, kids, now watch. Hey, kids, inertia states that an object at rest will stay at rest at rest until an outside force is put on it for the object to move. Now, kids, when I taught physics, I would take a handful of rubber bands in between classes and I'd throw them in the middle of the floor. And the kids could never figure out how I knew that they had picked up the rubber bands and they were flying all over the room. They couldn't figure out, well, kids, it's the law of inertia. Those rubber bands would have stayed there forever unless an object made them move, or an 8th grader.
Like grabbing them.
Okay?
I know how to.
Kids, now maybe if there was a major windstorm or an earthquake or something like that, well, yeah, but we didn't have any of that. So I just figured it was an 8th grader. And I was right. Okay. Now, guys, once those rubber bands started moving, okay, inertia also says that if an object is moving, kids, it will continue to move until something makes it stop moving. That is Newton's law of inertia. Very good. Okay. Now, kids, I added some music from Madagascar. I like to move it, move it. But kids, you can listen to that later. All right. Now, moving on. Do we have this? I know. I'm with you. Thank you. Okay. Kids, now the laws of inertia, Gavin? Hey, no, that's not our problem. Okay, so kids, here are some epic inertia fails. Love this. Kids, so you can go through and take a look at what was moving and what made it stop. And obviously the bike was moving, the hillside made it stop, but it didn't make the rider stop. He kept going. Oh, okay. Now, kids, you can look at these. I love the law of inertia. It just makes me laugh. But guys, let's go on and get our last slide for today. Okay. In space, there is no air. Now, kids, air can be something that stops or slows down an object. But in space, guys, there is no air to cause resistance. I don't know, honey. Okay. Now, excuse me. Are you getting this no?
Yes.
No.
Yeah.
Okay. Therefore, kids, the planets will keep moving, but what keeps them from going into the sun?
Resistance. And inertia.
Gravity. Guys, each planet also has our own gravity. So as hard as the sun is pulling on us, kids, our planets are saying, no way, Ray.
We have gravity.
We have gravity too. You stay in your own lane.
You're not special. You just have more than us.
Yeah. Now, guys, look right here. Eyes right here. Okay. We have an orange box. It's the only one for this week.
Kepler.
Okay. Kids, compare the findings of Kepler with the findings of Newton. Okay. Guys, how many laws did Kepler have?
Like,
in fact, I'm going to add a text box.
probably about 4, maybe.
No, we did this last week. Look back in your notes. How many laws does Kepler have?
Oh, okay.
How many laws does Kepler have?
I can't see it because all my.
Honey, you have your virtual notebook on your computer.
I'm talking about my. This is broken. Like you can't see any pictures.
Well, you're gonna have to figure that out.
Yeah, I guess so.
Okay. Kids, what are Kepler's laws? What does the law of gravity say? And I'm gonna add a text box for that. Got it? Now, kids, this has to be done for next Wednesday. Thumbs up, okay? Kids, your science worlds need to be filled in for next, no, for next Wednesday. How do I stop recording? Okay, what is this one? Stop? Nope.